Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into a very interesting concept of cliques and communities. We will also look into an example of it. So let's start with the overview of clique. What exactly a clique is. So in simple terms, it is a subgraph of nodes that are tightly connected with each other in a given large network. Tightly connected nodes means the nodes that are involved in a subgraph forms a complete graph. So this is the simple definition of clique. In a clique, every node is directly connected to each other node that is involved in the subset. Mark the word every. Each and every node is connected to every other node in the subset. Now, this clique is basically used to identify the groups of individuals or entities with stronger relationships in a particular network, which are nothing but clusters. In the previous video, we have seen one algorithm for identifying the communities, which was called as Girvan-Newman algorithm. The same task of identifying the communities is done with the help of the clique percolation method. And hence, clique performs a very important role in identifying the communities or clusters. And therefore, it is also used for understanding the patterns or the insights in the interconnections within the network. And once we get the patterns or the insights of given interconnection within the network, we can also get the targeted analysis of those subgroups in which those particular nodes that have stronger relationships or interconnection with the other nodes. So I hope an overview of what exactly clique is clear to you all. Now we will see some real life use cases of the clique. Now, clique is used in social network analysis widely. It reveals the tight social groups, that means those groups which have a stronger relationships between each other, their structures as well as the influences they have on the other groups. As I said already, it is also used for community detection. It identifies the related groups using cliques. And the method that is used for community detection is clique percolation method, which we are going to look into later on. One of the best use case of clique is the anomaly detection. That means it is used to detect the outliers or unusual behavior of nodes can be easily identified with the help of the concept of clique. Now, if you remember, one of the previous video was on collaborative filtering, in which we have seen how recommendations are made based on similar customers' choices. Now, with the help of clique, we can also do the same task of identifying the similar users' choices and recommending it to the other users. It is also used in computational biology, in which it is used to identify the structure of proteins as well as genes with the help of cliques. And most importantly, it can also be used in data mining for extracting frequent patterns. So I hope the real life use cases of cliques is clear to you all. Now we will see some examples of clique which will clear how you can identify a particular clique based on the number of nodes that are involved in it. Now let's say k is the number of nodes which are involved in a particular clique. Then if you want to draw the clique for k equals 2, that means that two nodes are involved in a particular network. If you remember the definition of clique, it means that all the nodes that are involved in the subset must be directly connected with each and every other node. So here you can see there are two nodes A and B, and both the nodes are connected with each other. Here A is directly connected to B as well as B is directly connected to A. Hence it is a valid clique for k equals 2. Now you can see on the right hand side we have two nodes again, but here none of the node is connected with each other. Hence it is not a valid clique for k equals 2. So I hope for k equals to 2 it is clear. Now we'll see cliques for k equals to 3. So by this we can understand that three nodes must be involved in the subset. So here are the three nodes A, B and C. Now here you can see that all the three nodes are connected to each and every other node. A is connected to B as well as A is connected to C, B is connected to A as well as B is connected to C, C is connected to A as well as C is connected to B. hence it is a valid clique. But if you see on the right hand side, we have again 3 nodes. Here A is connected to B is connected to C, and it is bidirectional, but still A and C are not connected to each other directly. Hence it is not a valid clique example for k equals to 3. Now similarly for this particular graph, you can see that again A and B are not directly connected, hence it is again not a valid clique for k equals to 3. In this case also you can see that B and C are not directly connected to each other, hence it is not a valid clique. So I hope the clique for k equals to 3 is clear to you all. Now we'll see clique for k equals to 4. By this you can understand that 4 nodes are involved in the subset. So here are the 4 nodes. The 4 nodes are A, B, C and D. Here you can see that every single node is connected to every other nodes. A is connected to B, C and D. B is connected to A, C and D. C is connected to A, B and D, as well as D is also connected to A, C and B. So you can see this is a valid clique for k equals to 4. Now, if you look at the right side, we have 4 nodes again, but in this particular example, you can see directly the A node and D node is not connected, as well as you can see the node B and C node is also not directly connected. Hence, it is not a valid clique for k equals to 4. Similarly, if you have this situation, here also you can see that A and D are not directly connected. In the next case, you can see that B and C are not directly connected. So I hope it is clear that every single node has to be strictly connected to every other node inside the network. Then only it will be called as a clique. So I hope the definition and the example of clique is clear to you all. Now we'll see the community. What exactly it is, we'll see an overview of it. So group of cliques that share k-1 nodes in common. It is called as community. Now we already have seen how to identify whether a subset network of nodes is a clique. Once we identify the clique, we can check for the neighborhood area of that particular clique. If the neighborhood area is also clique and both these cliques are sharing k-1 nodes in common, then it forms a community. I hope you must have got an idea of what exactly a community is. If not, then we'll see some examples of communities which will clear all your doubts. So here is the first example. We'll look for the community for the cliques k equals to 2. So here you can see that we have a graph which has 3 nodes A, B and C. A is connected to B and B is connected to C. Here you can see that A and B forms a clique because both the nodes are connected to each other. Similarly, B and C also forms one clique because both the nodes are connected to each other. So we have clique 1 as AB and clique 2 as BC. So if this particular graph has to be a community, both the cliques AB and BC must share k-1 nodes in common. Here k equals to 2, hence k-1 is 2 minus 1, which is 1. Here one node, that is B node, is common between both the cliques AB and BC. So by the definition we can clearly say that this is a community for k equals to 2 cliques. So I hope it is clear now for k equals to 2 how it forms a community and how to identify whether it is a community or not. Now we'll see for k equals to 3. Here we will see how to identify whether there is a community present for k equals to 3 cliques. Here we can see a graph containing 4 nodes A, B, C and D. Here by looking at the graph you can see that there are 2 cliques. First is A, B, C, because all the nodes A, B and C are interconnected directly with each and every other node in the network. Second clique is B, C, D, because all the nodes are directly interconnected with each other. Are there any other cliques of k equals to 3? No, right? We have only 2 cliques. Now you can see that as per the definition of community, it must share k-1 nodes in common. Here k equals to 3 and k-1 is 3 minus 1, which is 2. So 2 nodes must be in common with each other. Here you can see that 2 nodes B and C are actually common between these 2 cliques. Hence we can say that this is a community for cliques k equals to 3. So I hope all the examples of cliques and communities are clear to you all. So now we'll look into a big example for finding out the cliques and communities for k equals to 3 and 4. So here you can see that we have a big graph of total 8 nodes. Each and every node is connected to some other nodes in a particular fashion. Now we will look for all the cliques and communities for k equals to 3. So let's start with the clique for k equals to 3. So you can see that in the graph we have first clique as A, B and C. So we can write it like this. Clique 1 is A, B and C. In the graph we can see the next clique is C, B and D. Why they are clique? Because each and every node is connected to every other node in the subset. Now if you look at this particular section, you can see that in the section B, E, D, F, we do not have any clique of k equals to 3. Here if we look at the bottom section, we have one clique of the nodes D, G and H. Similarly, in this particular section, we have one more clique of k equals to 3 as F, G and H. Again, this is the clique 4. Now we have one more clique. If you carefully observe, the clique is of the nodes F, D and H. So this is one of the clique because every single node is connected to every other node in the network in this particular subset. So this is fifth clique. Again we have one more clique. If you carefully observe, the clique is of the nodes E, F and G. So here we have the sixth clique. Apart from this, is there any other clique? Just have a look at the entire graph. You can see that there is no other clique in this particular graph. So these are the 6 cliques which are formed with the help of k equals to 3 nodes from the entire graph. Now it's time to form the communities with the help of these cliques. Now since this clique is of k equals to 3, there must be k minus 1, that is 3 minus 1, which is 2 nodes in common between any 2 cliques. Then only it will form a community. So let's start with the first clique. Let's take all the nodes at the top A, B and C. Now from these nodes A, B and C, we'll have to check for each pair whether that particular pair is present in any other cliques or not. So let's take the first clique of nodes A, B and C. Now in this we'll create all possible combinations of the length 2 starting with AB. So let's highlight A and B. We'll check whether AB is present inside any of the cliques as a pair. So here you can clearly see that the pair AB is not at all present in any of the rest of the cliques from 2 to 6. Hence the pair AB is not shared between any 2 cliques, hence it won't be helpful for forming communities. So therefore clique 1 will be kept single. Now let's check for the another pair which is BC. So let's highlight it and let's check whether the pair BC is present in any of the other cliques. So clearly if you observe, you can see that in clique 2 we have one pair BC. That means 2 nodes B and C are shared among the 2 cliques, that is clique 1 and clique 2. So we can form a connection between the 2 cliques 1 and 2, and hence clique 1 and 2 forms one community. So therefore this is how the communities are formed. Now let's check for the next pair which is A and C. Let's check whether A and C are present as a common node between other cliques or not. So it is not present, therefore no community will be formed by sharing these 2 nodes as common nodes. Now the next clique contains the nodes B, C and D. Let's check for the pair BC. Whether BC is present in any of the other cliques rather than 2. Don't have a look at the clique 1 because we are already done with the clique 1. So BC is not present among any of the other cliques. Similarly, CD is also not present among any of the other cliques, and BD is also not present in any of the other cliques. Hence, no community will be formed based on these 2 nodes. Now let's have a look at the third clique nodes. First, we'll have a pair of DG. Let's check whether DG is present as a common node in any of the other cliques or not. In clique 6, you can see that DG is present. So we can have a connection between clique 3 and clique 6. So let's form the connection. So 3 and 6 cliques are forming a community. Now in the DGH nodes, the next pair is G and H. Now we'll look whether the pair G and H are present in any of the other cliques. So if you carefully observe, in the clique 4 we have the pair GH present. Therefore there is a connection that is present between the clique 3 and 4. So from 3 will form a connection to the clique 4 because 2 nodes G and H are common between them. Similarly, the next pair is D and H. So let's highlight it and let's check whether DH is present in any of the other cliques. You can carefully observe in the clique 5, we can see that D and H are present. So therefore, there is a connection from the clique 3 to clique 5. So this is how the connection will be made. So we are done with the DGH notes, which were from the clique 3. Now let's move on to the nodes of the clique 4, that is FGH. Let's look for the pair FG. Whether FG is present in any of the other cliques, you can see clearly that in clique 6 we have the nodes FG present. Therefore, there will be a connection from the node 4 to the node 6. Now let's look for the another pair, which is G and H. So let's highlight it and check whether G and H is present in any of the other cliques. So you can see that G and H is present only in clique 3 and 4, for which we have already made the connection. Now let's check for the other pair, which is F and H. You can see clearly the clique 5 contains the nodes F and H. So there will be a connection from clique 4 to clique 5. So let's make the connection. So now we are done for the clique 4. Now let's move to clique 5. The nodes are DFH. Let's check for the pair DF. DF is present in clique 6 if you carefully observe. So there is a connection between cliques 5 and 6. So let's make the connection from 5 and 6. Now you can see the next pair is F and H. We are already done for the pair F and H. If you remember, it was between clique 4 and 5. We are done with it. Next pair is D and H. We are already done with D and H also. Now next clique is DFG. So let's check for the pair DF. We are already done for the cliques 5 and 6. Now the next pair is F and G. Again we are already done for this. Next is D and G. Again, if you carefully observe, we are already done with this particular pair. Now you can see that finally we have got this particular figure as the resultant for the nodes k equals to 3. Since these two figures are independent of each other, there is no connection among these two figures, hence one of the figure will be called as community 1 and other figure will be called as community 2. So this is how we create the communities for cliques k equals to 3. So I hope it is clear to you all. This method is called as clique percolation method. So now we are done for k equals to 3. We are still left for k equals to 4. So let's start finding out the cliques for k equals to 4 nodes. So here are the following cliques. So if you carefully observe in the entire figure, you have 3 sections. In the first section, which is of the nodes A, B, C and D, you do not have the clique for k equals to 4 because there is no connection between A and D. But for a clique, there should be connection between all the nodes that are present in the subset. Similarly, in the next section, which is of the nodes B, E, D and F, there is no connection between B and F and D and E. So there is no clique in this particular situation. The next section is of the nodes D, F, G, H. You can see that in this particular section, every single node is directly connected with every single other node that is present in this particular subset. Hence, it is a valid clique for k equals to 4. Therefore, we have the clique 1 as DFGH. Apart from this clique, if you carefully look at the entire figure, we do not have any other clique for k equal to 4. Now, for a particular community to form, we should have at least 2 cliques and 3 nodes must be common between them. But here we have only one single clique for k equals to 4. Therefore, there will be no community for this particular situation. So I hope this entire example is clear to you all. Now we'll see one more example. This will be a short example. This is to find out the clique and communities for k equals to 3. So this is the figure. Here we have 2 sections A, B, C and D, E, F. B and D are connected with each other. Now if we are supposed to find out the cliques and communities for k equals to 3, first we'll have to find out all the cliques for this particular graph. So here you can clearly see that we can have only 2 cliques over here for k equals to 3. First clique is A, B and C. So let's write it. So clique 1 is A, B and C, and next clique we can have is of the nodes D, E and F. So let's highlight it and let's write it. So clique 2 will be of the nodes D, E and F. So these are the only 2 cliques that we can have for k equals to 3. Apart from this, there is no other clique that is present inside this particular graph. Now you can see that in these 2 cliques, we do not have any two nodes, that is k minus 1 nodes common between these two cliques. All the nodes are different from each other. There is no common between them. And as per the definition of community, there must be k minus 1 nodes in common to form a community. Hence, there will be no community for this particular figure. So I hope it is clear why we do not have any community that are formed in this particular figure. So now I hope the concept of cliques and communities with the examples of it is very much clear to you all. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. Don't forget to put your reviews as well as suggestions in the comment section, and please try to share this entire big data analytics playlist with your friends as well as juniors so that they will also get benefit out of this. Sharing is most important task. So please share, and also don't forget to subscribe to my channel. Also hit the bell icon to get notified regularly. Also hit like if you like this video, follow me on Instagram, and thanks for watching.